Let's take a look now at how to find the explicit form of a generating function. Again, I've included this just for your reference. I would certainly look back at this whenever necessary. We're going to start with the easiest of examples because in this example I actually don't have to do any work. So you might find yourself lucky to try to find the explicit form of a generating function that we already are familiar with. So in this case we have the generating function 1 over 1 minus 2x, which we can find from the series 1, 2, 4, 8, 16, and so on. Now, why is this one so easy? Well, if you look back at the table that we've just reviewed, we know that if I have 1 over 1 minus 2x, then to find a sub n, which remember, that's what I'm trying to find, is a sub n. So to find a sub n, my solution is just going to be 2 to the n. So that is, in fact, my explicit function to find the values in this series. So can I check them? Of course I can. A 0 would be 2 to the 0, which is 1. A 1, which would be 2 to the first, which is 2. A 2 would be 2 squared, which is 4. Do all of those match up with what I'm seeing here? Yes, of course. So that's a very easy example. This is just a geometric series, and my solution is whatever the value is here to the nth power. Of course, most of the time we're not going to be so fortunate as to be able to just look at a table and look at our prior knowledge on a subject. So instead, we have to figure out how can we actually solve to find the explicit form of the generating function. Now, in this case, you should be familiar with this question to a certain point. So when we learned in 8.4.2 how to deal with the fundamental identity and doing some manipulations, we said in order to get the series 1, 0, 1, 0, 1, 0, and so on, we would use the generating function g of x is equal to 1 over 1 minus x squared. What I want to do is at the end of this question, I really want to get down to the point that a sub n is equal to something where that something is a function of n. So how am I going to do it? Well, I'm going to start by writing the power series. The summation as n goes from 0 to infinity of a sub n x to the n is going to give me, in this case, 1 over 1 minus x squared. Now, 1 over 1 minus x squared can actually be factored. If we think about the difference of squares pattern, 1 over 1 minus x squared is 1 minus x, 1 plus x. So that's where I am right now. Now what I want to do is I want to rewrite 1 over 1 minus x, 1 plus x, and I want to solve for whatever coefficient I would use for those two factors. So this is partial fractions. I'm going to use, my two factors. I'm just going to use a and b, and I'm going to solve for both a and b using this exact setup. So how am I going to do that? Well, the first thing I would do is multiply everything. I'm going to do the whole thing. Everything times 1 minus x, 1 plus x. So if I multiply the first fraction times 1 minus x, 1 plus x, obviously we can see that 1 minus x would cancel, 1 plus x would cancel, that would leave me with just 1. So now let's do the same for a. If I take this fraction, a over 1 minus x would cancel, and that would leave me with a times the quantity of 1 plus x. And if I do that for the very last part, for the last fraction, I would get b, and then 1 plus x would cancel, but I would take 1 minus x. Now, distributing a and distributing b, I get a plus ax equals b minus bx, plus b minus bx. And then just putting like terms together, I get 1 is equal to, I have ax minus bx, so ax minus bx, and I'm going to factor out the x, and then plus, and then I have 1 times a plus b. So do I need to take the 1 out? No, of course not, but what might help this make sense to you is on the left-hand side of the equation I have 1, which can be written as 0x plus 1 is equal to a minus bx plus 1 times a plus b. So why do I do that? Well, because I need to write now a system of equations. So how am I going to write a system of equations? Well, I know that 0x is equal to a minus bx, so a minus b is equal to 0. And I know that 1 is equal to 1 times a plus b, so a plus b is equal to 1. Now all I'm trying to do is solve for a and solve for b. Well, that's going to be pretty easy using elimination. If I just add these two together, a plus a gives me 2a, negative b plus b gives me 0b, 0 plus 1 gives me 1, so a is 1/2. Plugging 1/2 into either equation, I'm going to choose the second equation, a plus b equals 1, so 1/2 plus b equals 1, subtracting 1/2 from each side gives me b is 1/2. So I get a is 1/2, and I get b is 1/2. Now, what am I going to do from here? I'm going to go back to basically where I started. The summation as n goes from 0 to infinity of a sub n x to the n is now I can rewrite 1 over 1 minus x 1 plus x as my partial fractions of a, which is 1/2 over 1 minus x, plus b, which is 1/2, and then 1 plus x. So you might be having a hard time seeing where we're going here, but essentially what I want to do now is do whatever substitutions I can. So I've got the summation as n equals 0 to infinity, and then a sub n x to the n. I've got 1/2, and then essentially that leaves me with 1 over 1 minus x. Well, I know 1 over 1 minus x is the summation as n goes from 0 to infinity of x to the n. And then I can factor out that 1/2 or pull it to the front. And then I have 1 over 1 plus x. And again, I know that that in fact is the series as n goes from 0 to infinity of negative x to the n. And you might be saying, well, how do I know that? Well, we went through this several videos ago, and we also included it in the table at the beginning of this video. I believe video 8.4.2 is where we were manipulating to find out these series. So now what? Well, now what I want to do is I want to think about how I can replace, whoops, I'm going to use a different color here. How can I replace this summation with whatever a sub n would be? And how can I replace this summation with whatever a sub n would be? Well, again, assuming that you've watched all of the videos in section 8.4 leading up to this point, we know that this first summation, a sub n, is always 1. 1 to the n in this case. And for the second summation, a sub n is always negative 1 to the n. And again, I'm building on knowledge that we've looked at previously. So what's 1 to the n? Well, 1 to the n is always 1. So as I'm writing my series, 1/2 times 1 is just 1. And then 1/2 times negative 1 to the n will stay just like that. So can I leave it like that? Absolutely. Do I have to leave it like that? No, I could factor out the 1/2 if I wanted to, but really I don't need to. So I'm going to say that a sub n is 1/2 plus 1/2 times -1 to the n. Now, of course, you can always plug in n is 0, n is 1, n is 2, and verify that you do in fact come up with these same values, but it should be pretty clear that you're going to. For our very last example, I wanted to look at a difficult example, and I chose this one specifically because in our next video, we're going to learn how to take a recurrence relation, which we should be familiar with because we've been working with recurrence relations, and we're going to learn how to model it as a generating function. In this video, we're working on how to take generating functions and write them explicitly. So we're going to work on the second half of this question, whereas in the next video, we'll work on how to get from the recursive relation to the generating function. So for this, notice that I have 1, 2, 3 separate generating functions. And I have to, essentially, what I'm looking for is what's a sub n for each of those. So for the first one, that one's one of those easy examples. This is one of the things that we talked about previously. We know if we have 1 over 1 minus 3x, then I can write that a sub n is going to be 3 to the n. So that's what this is, except it's multiplied by 2. So 2 times 3 to the n. That one didn't require any work. I didn't break a sweat. All I had to do was know that knowledge that we built previously. For the second one, as you can see, I've got x over 1 minus 5x times 1 minus 3x. And this one's going to require partial fractions. And just as I did before, I went ahead and set this up just for the sake of time and space, because obviously I'm dealing with a small amount of space here. So if I take everything here times 1 minus 5x, 1 minus 3x, on the left-hand side of the equation I'll have x, on the right-hand side I'll have a times 1 minus 3x, and then plus b times 1 minus 5x. Following the same steps that we did before, I would get a minus 3ax plus b minus 5bx. Putting those values together, I'll have x is equal to negative 3a minus 5bx, and then plus a plus b. So I'm just combining the terms with x's, combining the constants. From there, I have to write the system of equations. My system of equations is going to be that, keep in mind, this would be like 1x plus 0. So that means negative 3a minus 5b is equal to 1, and a plus b is equal to 0. Well, how do I solve a system of two equations? Well, substitution, elimination, matrices, pick your poison, whatever makes the most sense to you. I'm going to choose to take this function all multiplied by 3, or that equation, so I'm going to get 3a plus 3b equals 0. I'm going to solve that to find that negative 2b is equal to 1, so b is equal to negative 1/2. And if a plus b is equal to 0, then a plus negative 1/2 is equal to 0, so a is equal to 1/2. So where I am so far with my second expression is a sub n is equal to, and again, I'm just going to take that partial fraction, replace a with 1/2, so 1/2 over 1 minus 5x, and then minus 1/2 for b, so minus 1/2, 1 minus 3x. So there's my a sub n. This is my a sub n for my first expression, and now I have to do the last expression. So let's take a look at my last expression. Now this one's more complicated. Keep in mind I have a double root, and with a double root I write the single root the first time and the double root the second time. in case you've forgotten that about our partial fractions. And I'm going to follow the same steps. So I'm going to take everything here times 1 minus x quantity squared, 1 minus 3x. That's going to leave me with negative 2x squared is equal to a times 1 minus x, 1 minus 3x, plus b would just be times 1 minus 3x, plus c would be times 1 minus x quantity squared. I'm going to skip a little bit of the algebra here, just for the sake of our time and space. I know that I'm going to basically FOIL these out and then multiply them all by a, FOIL that out and multiply it all by c. That's going to give me negative 2x squared is equal to a minus 4x plus 3ax squared plus b minus 3bx plus c minus 2cx plus cx squared. And then again, I'm just going to combine like terms together. So combine all of the values with an x squared. And again, I'm showing less work than normal just for the sake of time and space. So 3a plus c quantity x squared plus negative 4a minus 3b minus 2c x, and then plus a plus b plus c. So what is my system of equations? I would have negative 2 is equal to 3a plus c. I would have negative 4a minus 3b minus 2c is equal to 0, since there was plus 0x over here. And I would have a plus b plus c equals 0, again because it was plus 0 on the left-hand side. Now, do whichever method that you like best in order to solve this system of three equations. So you can use matrices, you can use substitution, you can use elimination. It really doesn't matter to me. I'm going to cheat a little bit and just skip to the answer. But keep in mind, if you're like, whoa, that's cheating, I don't know how to solve a system of three equations, we did review it just a bit ago, and I'm going to spend some ample time on it on the next video. So in case you're feeling a little bit cheated that I'm not solving this in its entirety, watch the next video and I'll show you exactly how to solve a system of three equations. So when I do, I get a equals negative 1/2, b equals 1, and c equals negative 1/2. Now, how do I put this all together? Well, I replace 2 over 1 minus 3x with a sub n, which is 2 times 3 to the n. I replace everything I've circled in green, whoops, all of this with a sub n, and it looks like I didn't quite finish this last question. This would be a sub n is equal to negative 1/2 over 1 minus x, so I'm just replacing a with negative 1/2, and then plus 1 over 1 minus x squared, and then minus, because c is negative, minus 1/2, and then 1 minus 3x. So where do I go from here? We got to put it all together. So I'm going to move this out of the way so it's a little bit less confusing. So notice this is the original function, and then I've replaced a sub n, or I've replaced the initial function with what I have for a sub n. I've replaced everything I found in green, and I've replaced everything I have in blue. And you might be saying, well, no, you didn't. You skipped some steps. Well, yeah, I kind of did. So let's take a look at the steps that I skipped. So how did I go from this expression to what I substituted in down here? Well, again, this is 1/2, and then it's 1 over 1 minus 5x. And this is 1/2, and then 1 over 1 minus 3x. So again, based on the same rules that I used here, this is 1/2, and then 1 over 1 minus 5x is just, again, we're going to use n, 5 to the n, and then this is 1/2, and then 1 over 1 minus 3x is 3 to the n. So that's where I got those two values. Same thing with everything that I have written in blue. So I have negative 1/2 and then 1 minus x. So that's just negative 1/2 times 1 to the n, which 1 to the n is always 1. So feel free to leave that 1 to the n out. This one was that tricky one. This is that tricky one where we had to use differentiation to find, but I can replace that with n plus 1. And then again, this one is 1/2 and then 3 to the n. And then all I did was combine any like terms that I could and find my final solution. So this is my final solution. I will leave it to you to check the values to make sure that you do get the correct solutions, but I have checked it a couple of times myself, and this is correct. So just a smidge over 20 minutes. Again, it's hard to get it all in one video, but up next we're going to take a look at solving recurrence relations with generating functions. So straight back to where we finished, we're going to talk about how to do the first half of that problem.